cup, and in this cup we have water. Then we place an ice cube in the water. What happens? Well, if the water is at a higher temperature, then it transfers some heat to the ice cube. And the ice cube will rise in temperature, and eventually it'll start to melt. Let's zoom in on this process. In black here, I have the ice cube, and then the blue is the liquid water. Why is heat transferred from the water to the cube? The answer is simple. If the water is at a higher temperature, then those molecules are moving faster. And so they will slam into the ice cube and transfer some of their kinetic energy to the ice cube. So Ke gets transferred from the water, the liquid, to the solid, the ice cube. And this happens through the collisions. Let's imagine that 10 joules of energy is transferred from the water to the cube. What can we say? Well, the water, the liquid, has lost 10 joules, and the ice cube has gained 10 joules. And what do we notice? We have now a relationship. The heat of the water is equal to negative the heat of the ice cube. So if both objects are changing temperature, and that's all, if they both change temperature, we would have an mc delta T for each. And we could put subscripts for water and subscripts for the cube. Notice we could multiply both sides by -1, and then the negative would cancel from the left side, changing over to the right side. Why did I do that? Well, because there will be scenarios where the cube raises in temperature, and then once it's at 0 degrees, it will melt. So to set up our equation, we would have this. Take a moment to appreciate what's on each side. The negative sign is because the gain of one object is a loss of heat by the other. On the left, we have mc delta T for the water, because the water only changes temperature. On the right side, what do we have for the ice cube? Well, we have ml because the ice cube is melting in this hypothetical scenario. But we also have an mc delta T for the ice cube because in the hypothetical scenario that I set up, the ice cube started at less than 0 degrees Celsius. So the ice cube had to rise in temperature and get all the way up to 0 degrees before it could start melting. So this is the kind of procedure we'll be following in future problems. We will set up Q equal to -Q, and the negative sign can go to either side, and usually it's easier to put it on the side with just one term, because otherwise, if you put it over here, you have to remember about the parentheses around the right side of the equation, and then you have to distribute the negative to everything in parentheses. So this is the procedure we'll be looking at in future problems. Q equals -Q.